Everyone's talking about scaling AI with more compute, right? But what if the biggest bottleneck isn't about hardware at all?
Look, we all get the standard playbook by now. Get more GPUs, scrape more data, build bigger and bigger models. We obsess over these scaling laws. But isn't there another side to this? I mean, how do we scale the actual human part of this, the brilliant people, and the breakthrough ideas that really push things forward?
So to really get at that, we kind of have to reframe our whole way of thinking. See, advancing AI isn't just one single path. It's actually got two very different but totally connected sides to it.
And this table here just lays it out perfectly. On one side, you've got resource scaling. That's the stuff we know. More compute, more data, more parameters. It's the industrial approach. But on the other side, you've got community scaling. That's about growing the talent pool, sparking more ideas, and just making all of this stuff more accessible to more people. It might feel like the fuzzier side of things, but it's becoming absolutely critical for unlocking whatever comes next.
So why is this community side so important right now? Well, it's because that resource-heavy approach is smacking right into a massive wall, a serious talent bottleneck.
Let's be real. The world of cutting-edge AI research is a pretty exclusive club. All the top talent is holed up in just a handful of big labs, which sends salaries into the stratosphere. The barrier to get in is just insane. You practically need a PhD and access to a giant, super expensive computer cluster. So the strategy right now isn't about growing the talent pool. It's just about outbidding everyone else for the few experts that already exist.
And that leads us to the real question we're digging into today. How do we break down those walls? How do we give every talented developer out there the tools they need to actually jump in and contribute to meaningful AI research?
Okay, so the key is to find a new way in, something way more accessible that just lowers that crazy barrier to entry. And the solution that's being proposed revolves around this really powerful concept called environments. So what exactly is an environment? Well, think of it like a self-contained little sandbox or a test track for an AI model. It's a setup that defines a specific set of tasks and a scoring system of rewards. It's basically a super clear, concrete way to describe the problem you want the AI to solve. I love this analogy. It's just perfect. Think about it. Anyone with a laptop can start learning to build a web app, right? The goal here is to make AI research feel the same way. To take it from this huge, abstract, intimidating thing and turn it into something tangible and approachable that you can actually build. So why do these things work so well? Well, a few big reasons. For one, they're simple to get started with, but they can scale up to model really complex problems. They also teach you as you go. You'll learn the core concepts just by building. And here's what's crucial. They force you to be scientific. You can't just vibe check if your model is getting better. You have to prove it with actual scores on defined tasks. And finally, they're incredibly versatile. You can use them for everything from simple evals to full-blown reinforcement learning.
And hey, this isn't just some abstract idea. There is a whole open-source toolkit out there designed to make this a reality for any developer. So let's crack open the toolbox and see what's inside.
This stack has three main layers. Up top, you've got the Environments Hub. Think of it like a GitHub, but for these RL environments. It's a place to share and discover them. In the middle, there's a library called Verifiers, which is like a box of Lego bricks, reusable parts that let you snap together environments for things like tool use or coding really fast. And at the bottom, you have the Prime RL Trainer. That's the powerhouse engine that actually runs the large-scale training.
Okay, so what does this look like in practice? Let's take a real case study. Wikisearch. The goal is to teach an AI to search Wikipedia for answers. So first, you define its tools, some search functions. Then you load up a bunch of questions. Third, you create the rules for scoring. It gets a reward for finding the correct answer. You tweak a simple config file, and then you launch the whole thing with just one command. That's it.
Okay, so we've got the theory, we've got the tools, but does it actually work? I mean, what kind of results can you get? This is where it gets really, really cool.
So let's start with a smallish 4 billion parameter model. Right out of the box, its performance on that Wikisearch task is, well, it's 55%. Meh. Passable, but not exactly amazing.
But now, check this out. After you train that same small model in the Wikisearch environment, its performance skyrockets from 55% all the way up to 89%. And here is the truly stunning part. For this specific task, that little custom-trained 4 billion parameter model is now performing right on par with GPT-4. I mean, think about that. A small, specialized model keeping up with one of the biggest models on the planet. And no, this isn't just a trick for making small models punch above their weight. This whole system is built to scale up big time.
In fact, the exact same stack is being used to train a monster foundation model. Over 100 billion parameters running on more than 500 GPUs. So it works for everyone, from a single developer tinkering on their own to a massive research lab.
So all of this is leading us to a final and honestly, a really important conclusion about where all of this is heading.
Here's the big takeaway. The future of amazing AI products isn't going to be just putting a pretty wrapper around a generic API from some huge lab. No, the real winners will be the products that deeply customize and train their own models for their specific use case to create the absolute best user experience. And this whole environment-based approach, it's the roadmap for how anybody can do exactly that.
And that leaves us with one last super exciting thought. Every time in history that we've democratized a powerful technology, put it in the hands of all the creators, we've seen an absolute explosion of innovation. So if any developer, anywhere, can now build and train their own specialized, high-performing AI model, what are they going to create next? What amazing new things are about to be built?